In this question, a balanced equation for the preparation of ammonia from nitrogen and hydrogen by Haber process is given. We have to identify the conditions in which the ammonia can be produced favorably. The effect of different factors on equilibrium can be explained by using Le Chatelier principle. According to this principle, if a dynamic equilibrium is disturbed by a change in conditions such as concentration, pressure or temperature, the position of the equilibrium will shift to counteract the change and restore a new equilibrium. If concentration of the reactant is increased after equilibrium, the forward reaction will take place to decrease it. If the concentration of product is increased, the backward reaction will take place. And the next one is effect of temperature. If temperature is increased after equilibrium, the endothermic reaction will take place. If it is decreased, to increase the temperature, exothermic reaction will take place. The next one is effect of pressure. If pressure is increased, the reaction will shift to the direction where the number of moles decreases and vice versa. Now let's come to the options given here. The first one is given as use of catalyst. Catalyst is an external substance that can be added to the reaction mixture to increase or decrease the rate of the reaction. But after equilibrium, the addition of catalyst has no effect, because a catalyst can increase both forward and backward reaction equally. So option A is the incorrect one, means addition of catalyst has no effect on this equilibrium. The second one is decreasing the concentration of nitrogen. As we discussed before, after equilibrium, if the concentration of reactant is decreased, they will increase the concentration of nitrogen by keeping the backward reaction. So here the backward reaction will increases and forward reaction will not increase. So option B is also wrong. And the third one is given as low pressure, high temperature and high concentration of ammonia. When pressure is decreasing, the reaction will come to the direction where number of moles increases. So here 1 mole of nitrogen and 3 moles of hydrogen are taken. So the total number of moles on the reactant side is 4 and that of product side is 2. So when pressure is decreasing, the backward reaction will take place, that is from 2 moles to 4 moles. The next one is high temperature. The forward reaction is exothermic because the delta H value is given as -Q. So when temperature is increasing, the endothermic reaction will take place. Here, endothermic reaction is the backward reaction, because in a reversible reaction, if the forward reaction is exothermic, the backward reaction should be endothermic. And the next one is high concentration of ammonia. When concentration of ammonia is increasing, to decrease the concentration, backward reaction will take place. Means ammonia will decompose to produce nitrogen and hydrogen. So option C is also incorrect. And option D is given as high pressure, low temperature and high concentration of hydrogen. When pressure is increasing, the reaction will move to the direction where number of moles decreases. So here we can say when pressure is increased, the reaction will move from 4 moles to 2 moles. It means the forward reaction is taking place. The second one is low temperature. When temperature is decreasing, the exothermic reaction will take place. So from this equation, it is clear the exothermic reaction is the forward reaction. So decrease in temperature will increases the forward reaction. And the last one is given as high concentration of hydrogen. When concentration of the reactant is increasing, they will try to decrease it by increasing the forward reaction. So option D is giving an effect in which they will favor the forward reaction. So the correct answer is option D.